What if you could predict a star's death? Not a supernova, but a massive, repeating explosion visible to the naked eye. The fuse is lit. For nearly 80 years, one star has been quietly gathering its strength. It is 3,000 light-years away, in the small constellation known as the Northern Crown. Its name is T Coronae Borealis, but astronomers call it the Blaze Star. This is not a single star. It is a pair, a massive dying red giant and a tiny dense white dwarf. Think of the white dwarf as a cosmic cinder, the Earth-sized remnant of a star like our own sun. The red giant is shedding its outer layers, a slow, continuous stream of hydrogen gas. The white dwarf's gravity is so intense that it pulls this gas onto its surface, forming a thick, unstable blanket. This process is a ticking clock. As the gas piles up, the pressure and temperature at the bottom of that blanket climb higher and higher. It is a slow, steady buildup toward a moment of unimaginable violence. T Coronae Borealis is a recurrent nova. It explodes, not once, but on a predictable schedule. The last time it erupted was in 1946. Before that, 1866. The cycle is roughly 80 years. Today, the blaze star is dimming. This is the final sign. The gas layer is so thick that it is blocking the light from the stars beneath. Astronomers call this the pre-eruption dip. The moment the temperature reaches about 20 million degrees Celsius, the hydrogen gas ignites. It is a thermonuclear runaway reaction. The explosion is not the death of the star, but a cosmic firework, a momentary flash of rebirth. In a matter of hours, the blaze star will brighten by over 1,500 times. It will jump from a dim, invisible speck to a star as bright as Polaris, the North Star. For a few days, it will be visible to the naked eye. This is the first time in human history that we have been able to predict such an event with this level of certainty. It is a rare opportunity to study a nova in real time, from the moment before ignition to the final blast wave. But what does a nova explosion 3,000 light-years away have to do with us, here on Earth? The answer lies in the very elements that make up our world. Novae are cosmic factories. They forge and scatter heavy elements, the building blocks of planets and of life itself, throughout the galaxy. Every atom of carbon in your body, every atom of oxygen you breathe, was once forged in the heart of a star. This is a story of cosmic recycling, and the blaze star is about to deliver its next shipment. If you find this journey into the deep mechanics of the universe compelling, take a moment to acknowledge the work of the scientists who make this knowledge possible. The energy released in this explosion is staggering. It is the equivalent of the sun's entire output over a period of about 50,000 years, compressed into a few days. The sheer power is difficult to comprehend, but the white dwarf survives. It is not a supernova, which is the complete final destruction of a star. The white dwarf remains intact, ready to begin the slow 80-year process of gathering fuel for the next explosion. The nova's blast wave will rush outward, colliding with the material the red giant has already shed. This collision creates a shock wave that will generate high-energy radiation, including X-rays and gamma rays. This is where missions like the Fermi Gamma Ray Space Telescope and the Chandra X-ray Observatory come in. They are positioned to capture this high-energy light, giving us a direct look at the physics of the shock wave. But the universe holds mysteries closer to home that are also driven by these immense forces. Consider the largest magnetic field in our solar system, the one surrounding Jupiter. Jupiter's magnetic field is 20,000 times stronger than Earth's. It is so large that if you could see it from Earth, it would appear 5 times the size of the full moon. This field is generated deep inside the planet. The Juno mission was sent to peer beneath Jupiter's clouds. It found that the magnetic field is not generated by a solid core, but by a layer of compressed, metallic hydrogen, a substance so strange it acts like a liquid metal. This metallic hydrogen is swirling and churning, creating a powerful dynamo, the engine of Jupiter's magnetic shield. It is a force that protects the planet and its moons from the constant barrage of solar wind and cosmic rays. But what happens when you cross that shield? What does the atmosphere of a gas giant truly look like? The Great Red Spot is a storm larger than Earth, raging for centuries. Data from Juno allowed scientists to simulate a dive into this colossal vortex. As you plunge through the cloud tops, the atmosphere is a chaotic, turbulent mix of ammonia and water ice. The pressure quickly becomes crushing, and the temperature rises dramatically. The Blaze Star and the Great Red Spot are separated by light years, yet they are connected by the same fundamental physics, the immense power of gravity, pressure, and thermonuclear reaction. The Blaze Star is a reminder that the universe is not static. It is a place of constant, violent change, operating on cycles far beyond our human lifespan. We are simply here to witness the show. The explosion is inevitable. It is a promise that will be kept. But the true mystery is not when it will happen, but what new secrets we will unlock when that ancient light finally reaches us.